We are going to talk today about applications of Ario, which is the tool that we learn to assess qualitatively the strength of acids and bases. So in previous videos, so today is mostly problem. This is application, but we need to remember that what this means. So this is atom, where the negative charge is in the conjugate base of an acid. For example, the R is for resonance effects. Then the I is for inductive effects. And remember, this is related to differences in electronegativity. We're going to talk about polar bonds here. And last here, O is the orbital. So we're going to check out where the charge is and what atom, what is the hybridization on that particular atom. So let's go and apply that in a series of compounds. So here I have, say, some compounds that we're going to decide which is more acidic and why. So say that I have this compound now, and it has, I'm reading that from my paper. Here we go. So now let's label some of the hydrogens. I'm going to say hydrogen type A, and I'm going to say now, I'm going to put here B. This is the same. And let's label that one here. Well, that will be about the same. Well, okay. And so now, when I see those compounds and I want to assess what hydrogen would be more acidic, then I am going to form the conjugate base. So let's say that I remove the hydrogen A. When I do that, now I'm going to make another drawing. So I am removing proton A, and if I do that, the one that's on that label, I am going to form the following conjugate base, and here is an oxygen. Now, that charge is on an oxygen. Okay, so now let's remove one of the hydrogens, label B. So label B, oxygen here, and we said that now we're keeping this one, and if I remove one hydrogen B, I'm going to make this an ion. And now we're analyzing what is the difference between those two. So this is conjugate base, say A, because I removed proton A. This is conjugate base B. And because I'm writing our room on that side, I'm going to draw, what if I remove hydrogen C? So I'm going to draw another conjugate base, keeping this one, keeping those two, and removing just one of the hydrogens here. I'm going to form this anion. Now let's analyze the effects on that. So first of all, I want to look at the atom. So A, B, and C. These are my anions that I want to analyze. Okay, so I see here that the charge is on an oxygen. Here is on carbon. And other than that, I don't see any resonance effects. So by just looking at the charge, oxygen, the negative charge, is better supported at an oxygen, which is more electronegative. So these hydrogens are more acidic than the others because that negative charge is more stable. So charge, negative charge is more stable at that oxygen than it is on this carbon. Now, analyzing what is the structure, C, that was too big. C and B, I am looking at now charge on the carbon, charge on a carbon, and I am missing some lone pairs here. I know that oxygen has that. But let's see if we can decide which of these is more acidic. So now, when I'm looking at the charge here, I have an electron withdrawing by induction. I have that oxygen here that will move electron density towards there. So some inductive effect. But here I do have the same and at about the same distance. So really I cannot tell the difference using that tool from those two, say, type of hydrogen. So but bottom line, the strongest, the most acidic hydrogen in this molecule is this one here, because you're making a more stable anion. So we're gonna do more of this in other videos.